Yes, student, similarly, different type of compounds are also formed by the alkali metals, like alkali metals sulfates, okay, having the general formula, the general formula, what? Now, sulfate has valency 2 and alkali metal has 1. Therefore, the formula will become what? M2SO4, where M is alkali metal, like Li2SO4, like sodium sulfate Na2SO4, potassium sulfate K2SO4. Okay, these potassium sulfate, sodium sulfate are called very important fertilizers, okay, which is used to increase the crop yield. That is what their quantity. Student, the properties of these sulfates are again depends on the lattice enthalpy and the hydration enthalpy. Like what? Stability. As we discussed in the earlier compounds of alkali metal, the same phenomenon we can also apply in the stability of sulfates. Student, you know that the sulfates are quite bigger in size, while the alkali metal size increases down the group. So as the size of alkali metal will increase, it can stabilize the bigger size of sulfate ion. That means we can say down the group, the stability of sulfate increases. Stability means thermal stability. Similarly, all these sulfates are also soluble in water. Okay, but the solubility will decrease down the will decrease. That is what Li2SO4, being its lattice enthalpy is lower, therefore its solubility will higher, and the K2SO4, its lattice enthalpy is higher, so its solubility will be lower. Okay, so the same phenomenon like the thermal stability, like the solubility and the reactivity, we can apply as we applied in halides, okay, and hydrides also. Next one is nitrates of alkali metals, Now, the nitrate is denoted by what? NO3, and its valency is only 1. Therefore, the metal whose valency is also 1, therefore the general formula will become MnO3, like LiNO3, like sodium nitrate, like KNO3. Okay, again NO3 is bigger in size, while the alkali metal size increases, and therefore the thermal stability will increase down the group. Okay, similarly, if we think about their solubility, the solubility will decrease. The solubility is actually inversely proportional to the lattice enthalpy. It is, again I am repeating, to be soluble in water, it is necessary that very first the crystal lattice should break in cation and anion. If higher will be the lattice enthalpy, that is the difficult to break down the bond, and if difficult to break down the bond, the solubility will decrease. So this is about the sulfates. So student, here we are asking the question, okay, in the form of comparison of solubility or the stability, and you have to give the reason. So while solving this type of conceptual question or reason based question, you have to apply the two factors, lattice enthalpy and the solubility. Okay, again student, the nature of bond is also changed, okay, which depends on the size of cation and anion. Okay, like if we discuss in the case of halides, like LiCl. Okay, here LiCl, smaller size of Li and bigger size of Cl. isn't it? So if Li is smaller and Cl is bigger, then there will be covalent character develop, because small size of Li can distort the bigger size of anion, and therefore it shows what? Covalent nature. Also, LiCl is highly deliquescent compound. Deliquescent means it gets hydrated very easily by the atmospheric moisture, like common salt. Okay, generally we are denoted it by NaCl. Okay, but the table salt, which is the mixture of various type of alkali metal halides, so when it put open, it immediately absorb the moisture. This property called deliquescent. So NaCl is not deliquescent. However, the table salt get moisturized easily. Why? It is because table salt is not a pure NaCl, but large number of other alkali metal halides are present with the NaCl, and they are showing deliquescent property, while NaCl do not. But being their presence is there with NaCl, and therefore it gets moisturized easily.